Good morning, afternoon, or evening. This video is going to cover the distributive property guided notes. Now, the distributive property is a really important property in math. We use it for a lot of different things, especially in simplifying expressions, and we'll actually do the reverse of the distributive property later on when we factor using the greatest common factor. So it's going to be something we're going to use throughout the rest of this school year, and you'll use in years to come. So when we talk about the distributive property, I did represent this using variables here, but all we're doing is we're multiplying the number that's outside the parentheses by each term that's inside the parentheses. So we're distributing the a to both the b and to the c. So we're taking a times b plus a times c, or a times b minus a times c. To distribute means to give out to each person or each thing. So in this case, we're going to multiply the number that's outside the parentheses by each term that is inside the parentheses. All right, so let's get right into our practice. In our first set of exercises, we're going to use the distributive property to write each expression as an equivalent algebraic expression. So in this first problem, we have 3, and then in parentheses, x plus 1. So I have to distribute the 3 to both the x and to the 1. So that means I need to take 3 times x plus 3 times 1. Now this simplifies to 3x plus 3, since 3 times 1 is 3. Again, we can probably go right from the very beginning to this step, and our goal is to get there, but I'm always going to show this middle step at least for today's lesson, since we're just beginning with this. 3 times x is 3x, 3 times 1 is 3. All right, number 2, I do suggest taking the 5, moving it in front of the parentheses. We're allowed to do that because multiplication is commutative, which means we can do it in whatever order we want. And now we need to distribute that 5 to both the y and to the 4. So we're going to take 5 times y plus 5 times 4. 5 times 4 is 20, so we get 5y plus 20. Now keep in mind, our final answers are going to look like this. We don't combine 5y plus 20 to get 25y because those are not like terms, so we cannot add them together. All right, let's take a look at a third example. In this third example, we need to distribute the 4/5 to both the a and to the 5. So we have to take 4/5 times a plus 4/5 times 5. 4/5 times 5 is going to get us 4, so our final answer is 4/5 a plus 4. In number 4, we are going to distribute this -3 to both the x and to the 4. So we're going to take -3 times x plus -3 times 4. That will simplify to -3x plus -12. Now keep in mind, when we have two things in between like we do here, we have this plus and negative, we can replace that with a subtraction sign. It's writing it in a simpler way. We can rewrite this expression as -3x minus 12. Let's take a look at number 5. In this problem, we need to distribute the -2 to both the y and to the 1. So we'll have -2 times y minus -2 times 1. Now, as you can see, this is the first example where we've had subtraction inside the parentheses. So again, make sure we bring this subtraction down. -2 times y minus -2 times 1. -2 times y is -2y. Bring down our subtraction. -2 times 1 is -2. But again, we've got two things in between, minus and negative. We can rewrite that in a simpler way. Minus and negative is the same thing as addition. So we can rewrite this as -2y plus 2. In number 6, we need to distribute this 9 to both the -3m and to the 2n. So we will do 9 times -3m plus 9 times 2n. 9 times -3m is -27m. 9 times 2n is 18n. Now, you might be wondering, why are we allowed to multiply things that aren't like terms, but we can't add or subtract things that aren't like terms? Well, keep in mind that 9 times 2n is really like 2n being added 9 times, which would get us 18n's. So we are really actually adding like terms here when we take 9 times 2n. We can represent that as both an addition problem or a multiplication problem. So I know that that can get kind of confusing. We have lots of sort of strange rules in math, but again, we're allowed to multiply things that aren't like terms, just not add or subtract them. All right, let's take a look at number 7. The first thing I did was rewrite this with the 4 out front. I'm going to distribute that 4 to the 4b and the 4 to the 3c. So we'll have 4 times 4b minus 4 times 3c. That will simplify to 16b minus 12c. In number 8, let's distribute this negative 6 to the 2x and to the 1. So we'll have negative 6 times 2x minus negative 6 times 1. Negative 6 times 2x is negative 12x. Bring down our subtraction, and negative 6 times 1 is negative 6. Again, we don't want to leave this as minus a negative. Subtracting a negative is the same as adding a positive. So we can rewrite this as negative 12x plus 6. Number 9, let's distribute this 4 to both the 3x and to the 2y. So we'll have 4 times 3x plus 4 times 2y. That will simplify to 12x plus 8y. In our next example, let's distribute this negative 5 to both the 4a and to the 3b. So we'll have negative 5 times 4a plus negative 5 times 3b. Negative 5 times 4a is negative 20a. Negative 5 times 3b is negative 15b. Again, since we have two things between plus a negative, we can rewrite that as subtraction. So we can rewrite this as negative 20a minus 15b. In number 11, it says that Alberto is X years old. His brother Juan is 2 years older than Alberto. Their Aunt Maria is 3 times as old as Juan. Write and simplify an expression that represents Maria's age in years. Well, I've got 3 different blanks here. One for Alberto, who is X years of age. And then we have Juan, who is 2 years older than Alberto. So to represent 2 years older than Alberto, who is X years old, we can write that as X plus 2 or 2 plus X. Now, their Aunt Maria is 3 times as old as Juan, and we just represented Juan's age as X plus 2. So we can represent this as 3 parentheses X plus 2, 3 times Juan's age. We can rewrite that using the distributive property as 3x plus 6. 3 times x is 3x, 3 times 2 is 6. Number 12 is an error analysis question, so let's read through the problem. Billy, Johnny, and Randy are simplifying expressions using the distributive property. Look at their work for one problem below. They all did the same problem. Who is correct? Explain your reasoning. Let's look through the work. As I look through the work, I notice that one person is correct. And I hope you are thinking the same person. That's Johnny. The mistake that I noticed that Billy made is that Billy forgot to distribute the 4 to the 2. When I look at Randy's work, he remembered to distribute the 4 to both the x and to the 2, and he got 4x plus 8. But he went a little too far, and he combined 4x and 8 together, even though they aren't like terms. We're not allowed to do that. That's going a little bit too far with the problem, and it's not going to give us the correct solution. So what I would say for this problem is Johnny is correct. We can see that he distributed correctly, taking 4 times x and 4 times 2 to get 4x plus 8. Billy forgot to distribute the 4 to the 2, and Randy added 4x and 8, even though they aren't like terms and cannot be added. There's no time where we'll add things that aren't like terms together to get something like 12x when it's just 4x plus 8. Now we're going to talk about some perimeter problems here, and I want to review some basic problems first before we get into the algebraic questions, because we're going to start to mix simplifying expressions with the distributive property, which can get pretty complicated, and by the end of the unit it will be something that's pretty tricky. So a review for us is that perimeter is the total distance around the outside of a figure. So some examples that we'll talk about later on this year will be putting up fencing in a yard will represent perimeter. or if we're looking at putting a border around the outside of a room, for example, like a baseboard, for example, or we're putting some sort of wallpaper around the room, we could be looking at perimeter and surface area, just depending. So these are some different things where we might use perimeter in real life problems. Fencing is a really big one, and again, putting baseboard in a house is another really good example of perimeter. So if I ask you to find the perimeter of this triangle, all we would do is add the outer edges. So we would add 7 plus 12 plus 8 in whatever order. When we add those together, that gets us 27 meters for the perimeter. Now, this triangle is what we would call an isosceles triangle. It tells us that in the problem. An isosceles triangle means that we have two sides being the same length. This side is 8 inches, and sometimes we'll throw some little tick marks in here to indicate that both of these sides have the same length, but we can tell that they look more similar in length than this bottom edge that we have. So this side is 8 inches, so to find the perimeter, we do 8 plus 4.5. When we total those, that gets us 20.5 or 20.5 inches. Now let's throw some variables into the mix. If I want to find the perimeter of this triangle, I'm just going to add all of the outer edges in whatever order I want. So we've got 2x, which is this side here, plus x minus 2, which is this side here, and I did drop off the parentheses, that's okay to do here, plus our third side, which is x plus 4. Now, before I go to reorder these terms, I'm going to write this minus 2 as plus a negative 2. I also added a 1 in front of this x and a 1 in front of this x. So minus 2 became plus negative 2, x became 1x. Put our like terms, the 2x, the 1x, and the 1x side by side. I'm going to go ahead and highlight those. Again, that came from this, plus this, plus this. That became this part. And then we have our constants of negative 2 and positive 4, and I put those side by side. Again, I want to remind you that we want to make sure to rewrite everything as addition first before we start to move those terms around. 2x plus 1x is 4x. Negative 2 plus 4 is 2. So our solution here, it looks kind of weird, it's algebraic. We get 4x plus 2 meters. Let's look at another example. Here's that isosceles triangle again. Since this edge or this side is 2x plus 1 inches, so is this side here. So I represented the perimeter like this. X for this bottom edge plus 2 times the 2x plus 1, since I have two sides of length 2x plus 1. Now, you could have also done x plus 2x plus 1 plus 2x plus 1. Now, the next thing I'm going to do here is I'm going to distribute. I'm going to do 2 times 2x and 2 times 1. And so I will have 1x plus 4x from the 2 times 2x plus 2 times 1, which is 2. 1x plus 4x simplifies to get us 5x, so we end up with 5x plus 2 inches. Now, our book goes pretty complicated pretty quickly. So we have two triangles here, and the first thing that we want to do is represent the perimeter of each triangle with an expression in simplest form. So let's begin with triangle 1. So I'm going to add these three sides together, and I represented this with 3x plus 6, that's from these two sides, plus 2, and then in parentheses, negative 2x plus 16, which is this third side. Before I go to combine any like terms, I need to distribute this 2 into the parentheses. So let's see what we have, and then we'll talk through this. So I brought down my 3x plus 6. 2 times negative 2x is negative 4x. 2 times 16 is 32. Now the next thing I'm going to do is put my like terms side by side. So we have this 3x and this negative 4x. We have our constants of 6 and 32. So I wrote this as 3x plus negative 4x plus 6 plus 32. 3x plus negative 4x is negative 1x. 6 plus 32 is 38. We can write this as just negative x plus 38, but negative 1x plus 38 works fine as well. So that is our expression in simplest form to represent the perimeter of triangle 1. Let's talk about triangle 2. So I represented this as 3x plus 8 from this side and this side, plus 2 and then in parentheses 5x minus 14 for this third side. Now let's distribute. We have to take 2 times 5x minus 2 times 14. So we can write this as 3x plus 8 plus 10x from the 2 times 5x minus 2 times 14, which is 28. Now before I go to combine like terms together, I'm going to rewrite this minus 28 as plus a negative 28. My like terms that I'll put in order will be 3x and 10x. And then of course we have our constants of 8 and negative 28. So we've got 3x plus 10x plus 8 plus negative 28. 3x plus 10x is 13x. 8 plus negative 28 is negative 20. Now since we have plus a negative here and two things in between, we can replace that with subtraction. So we can write this as 13x minus 20. Now part B asks us to determine which triangle has a greater perimeter if x equals 4. So let's take our expression to represent the perimeter of each and replace x with 4. So for triangle 1, that was this negative x plus 38. That's going to be negative 4 plus 38, which is 34. Now, you could also go back to the original triangle and replace x with 4 each of these places to find the side length. So we know this side length is 6. This side would be 3 times 4, which is 12. This side we would do negative 2 times 4, which is negative 8, plus 16, which is 8. 8 times 2 would make this 16. And if we do 16 plus 12, we get 28, plus 6 would get us 34 for the perimeter. So we could do that as well, but that's a little bit more work, but it is a good way to double check our algebraic expression from part A. For triangle 2, we had the expression 13x minus 20, so replace x with 4 and do 13 times 4 minus 20. That will get us 52 minus 20, which is 32. Again, we can go back and replace x with 4 to find each of these missing side lengths and then add them all together, especially if we want to double check our answer, but it will be 32. Now, which triangle has a greater perimeter? Well, triangle 1 does when x equals 4. It's 2 more than it is for triangle 2, so triangle 1 has a greater perimeter. Let's take a look at another one of these. In fact, these are quadrilaterals here, so we need to represent the perimeter of each quadrilateral with an expression in simplest form. So for quadrilateral 1, let's add all of these side lengths. We have 5x for the bottom, plus 4x plus 6 for the top, plus 6 for this right-hand side, plus 2 parentheses 2x minus 3 for this left-hand side. Let's begin by distributing. So take 2 times 2x minus 2 times 3. So this will become 5x plus 4x plus 6 plus 6 plus 4x minus 6. 2 times 2x is 4x, 2 times 3 is 6. Now I'm going to rewrite this minus 6 as plus a negative 6, so the only thing that changed from here to here is minus 6 became plus a negative 6. We have lots of like terms to combine. We've got 5x plus 4x, and we have 3 different constants, 6, 6, and negative 6. So we can represent this as 5x plus 4x, which will total to get us 13x. 6 plus negative 6, well, this is actually a 0 pair and cancels out, so we end up with 13x plus 6. Let's take a look at quadrilateral 2. I represented this with this expression. 3x plus 2x plus 4 for the bottom, plus 12 for this right-hand side, plus 3 parentheses 3x minus 7 for the top. Let's go ahead and distribute here. So we're going to take 3 times 3x minus 3 times 7. So bring everything else down. 3 times 3x is 9x, 3 times 7 is 21. Again, like the last problem, let's rewrite that minus 21 as plus a negative 21. Let's put our like terms side by side. So we have 3x plus 2x plus 9x. 3 constants, we have 4 plus 12 plus negative 21. So when we put those like terms side by side, 3x plus 2x plus 9x is going to get us 14x. 4 plus 12 is 16, plus negative 21 is a negative 5. Now since we have plus and negative, we can rewrite that as subtraction. So we can rewrite this as 14x minus 5. Now we're comparing the perimeter of those two quadrilaterals when x equals 3. So let's replace x with 3 in each of those expressions. So for quadrilateral 1, we have 13x plus 6. That's going to be 13 times 3 plus 6. 13 times 3 is 39, and 39 plus 6 gives us a perimeter of 45. For quadrilateral 2, our expression was 14x minus 5. Replace x with 3, so we do 14 times 3 minus 5. 14 times 3 is 42, and 42 minus 5 gets us a perimeter of 37. So which quadrilateral has a greater perimeter? Well, that's quadrilateral 1 with a perimeter of 45. Again, you could go back to your original quadrilaterals and replace x with 3 to find those sides and add them together. It is a good way to double check, but it does require more work than in part B if we choose to go that route. Now, I know we covered a lot in this lesson. The distributive property is really going to be important moving forward, so please make sure you know how to do it. In addition to that, we really want to make sure that we know how to work through these problems related to perimeter. We will continue to see those throughout the unit. So definitely ask questions if you're struggling with the perimeter problems. Again, I think these last two are pretty tricky, but it is good to challenge us a little bit. Thanks for listening.